So you're going to draw a number line. And I'm not that teacher that makes you put 5 numbers on every number line. Okay, I don't care if you put 5 numbers on your number line. I know you know which way numbers go and what order they go in. All I want you to do is put the 2 numbers that are in your problem on your number line and make sure the small number goes on the left and the larger number goes on the right. So the -2 would go on the left and the 4 would go on the right. Now, all of these problems should have the small number on the left and the larger number on the right because we read from left to right, okay? And we want our numbers to be in order from the smallest on the left to the largest on the right, just like they would be on a number line. The parentheses means open circle. So somewhere on your notes, you might want to do a parentheses. It means open circle. And a bracket means a closed circle. So back in Algebra 1, when we were graphing, if we had an equal sign, we put a closed circle. Y'all remember that? If we had less than or equal to or greater than or equal to, we put a closed circle. If we just had a less than or we just had a greater than, we did an open circle. So once you get to Algebra 2 and any math higher than that, they stop doing that whole open circle, closed circle thing. And they use a parentheses for an open circle, and they use a bracket for a closed circle. So what you're doing here is you are shading all of the numbers between -2 and 4. You're shading all the numbers in the interval. Okay, that means from one thing to the other, from -2 to 4. So you would actually shade in between here. You don't have to have a colored pencil. You just shade. At -2, you're going to have a parentheses. And at +4, you're going to have a bracket. So parentheses, -2, comma 4, bracket means all of the numbers, decimals, fractions, all of the numbers between -2 and +4. Now the parentheses means we haven't shaded -2. So -2 is not in that interval because of the parentheses. +4 is in the interval because we use the bracket. So the parentheses is like an open circle. We haven't shaded -2, but we shaded all the way up to -2. So the graph approaches -2, but it doesn't actually get to -2. All right, that's what your graph would look like. And then they ask you to write, they ask you to express this in set builder. So this is where you use less than or greater than signs. So we're going to put an X in the middle. We're going to put the small number on the left, the larger number on the right. So we're going to say we are shading all of the numbers between -2 and +4. And to say between, we have to use 2 less than signs. Small number on the left, large number on the right. We use 2 less than signs, and then you would have to put the equal sign over on the 4 because I have a bracket beside the 4. All right. So this notation right here is called set builder. It's what you've probably seen the most of, and then this notation here is called interval notation. It's the new notation. It's used mostly in higher level math. It's not that bad. It's just something new, okay? And it's what you use from Algebra 2 on up. You don't usually see -2 is less than x and x is less than or equal to 4. So in number 2, let's draw our graph. We'll draw a number line. We're graphing the interval between -2 and +5. That's all the numbers between -2 and +5, decimals, fractions, integers, 0, every single number on the number line between -2 and 5. I have 2 brackets, so on my graph, I'm going to do bracket, bracket, and then you're going to shade all the numbers. So you would shade all the numbers between -2 and 5. So -2 is considered shaded because the bracket means closed circle. +5 is considered shaded because it is a bracket. All right, give me some other numbers. Give me a decimal that I've shaded. 1.5. Give me a fraction that I've shaded. 3/4. Okay? So we can't list all those numbers, and that's how we actually list a lot of numbers. We do something called interval notation, or you might see it in graph form. So in Set Builder, again, you put the small number on the left, you use a less than sign, you put your variable in the middle, you use another less than sign, and you put the positive, the larger number on the right. Because I have two brackets, then that means I need two equal signs. Alright? So just to show you Set Builder, if I covered this part up and you read it from the X, this would be all X's that are greater than or equal to -2. So we've shaded greater than, -2 would be to the right. And if I covered this part up, this says X is less than or equal to 5. So we've shaded all the numbers that are greater than or equal to -2, and we've shaded all the numbers that are less than 5. That means we've shaded between -2 and 5. You always use less than signs as long as you put the small number on the left and the larger number on the right. Okay? Alright, so in example 3, we have a new little symbol there. Does anybody know what an 8 laying on its side is called? Infinity. So we can't put infinity on our number line because infinity is not an exact number. So all we can put on our number line is the 3. And we're going to use a parentheses at the 3, meaning we're not going to graph the 3. It's not included in our points. And then we're going to shade to positive infinity. So that would be positive infinity. If it was a negative infinity, there would be a little negative symbol to the left of the 8 laying on its side. So we're shading from 3 all the way to forever and ever and ever and ever and ever to the most positive number that you could think of, to the largest number in the world. So that's what your graph would look like. Now you're not going to have two numbers when you do Set Builder. You're just going to have one number. And so have I shaded numbers that are larger than 3 or smaller than 3? They're all larger. So I'm going to use greater than 3. I don't have two numbers in this problem. I only have just the 3. I've shaded all the numbers that are greater than 3. Are those the numbers that are greater than 3 or greater than or equal to 3? Just greater than. Parentheses means not equal to. So I haven't shaded the 3. I've shaded all the way up to 2.999999999, but the 3 is not included in my solutions. All right, example 4. You got your number line. We only have one number. That's 2/3. Bracket or parentheses at 2/3. A bracket. And some people get confused about which way the bracket is going to go. It's going to go the way you're shading. And since I have a negative infinity symbol there, then my bracket's going to go to the left. It's going to open to the left because I'm shading to the left because I'm shading to negative infinity. You'll shade your arrow anytime you have negative infinity or positive infinity.
Do we not have to do the circles?
Do you not have to do the circles? We're converting over to something bigger than circles and closed, so open circles and closed circles. So the parentheses on your graph means open circle. Does that make sense? Is that what you're asking? Okay. So we don't have two numbers on this graph, so we're not going to have two numbers when we write Set Builder. So is this going to be X less than or X greater than? It's going to be X is less than. Is it going to be less than or equal to? Yes, because a bracket means closed circle. And a closed circle means an equal to. So we're shading all the x's that are less than or equal to 2/3. All right? Is there anything about those 4 problems? And again, I don't think you've ever seen interval notation before. I think you've seen Set Builder. I think you've seen these less than or greater thans. But the interval is new. So please ask questions if you can think of what you need to ask. Any questions? Okay, so the next part is a symbol that we studied back in our wonderful chapter P. What are these symbols called? Intersection and union. Okay, so let's go over what does intersection mean? Okay, she said in common, you said differences. That's the opposite. Intersection is what the two graphs have in common. So an intersection, you got to see what's in the first interval that's also in the second interval. Union is where you just take everything from both sets or both graphs. Okay? It says use graphs to find each set. So what you're going to do is you're going to make a number line, and you're going to graph the first interval. What I like to do is I like to go ahead and put the numbers in order. Okay? So I've got 4 numbers. Let's do that. What's the smallest number that you see up there? -4, and then -2, and then 0, and then 1. I don't care if they're spaced out like they're supposed to be. That really doesn't matter. Just make sure that they're in order from the smallest to the largest. Okay? Graph the first interval. It goes from -4 to 0, parentheses on -4, parentheses on 0. So here's my first interval. And then what I like to do is I like to graph the second interval above the number line so I can see where the second one is, and then I can see what the two graphs have in common. So the second interval has a bracket at -2 and a bracket at 1, and then we're shading between -2 and 1. So you're visually graphing here. You're looking at your graph, and you're seeing where the graphs have points or numbers in common. So do y'all see the overlap there? Okay, so this is where you're looking at the overlap, right there. And Abby says -2 to 0. I'll agree with that. Do both graphs have -2? Does the bottom graph have -2 shaded? Yes. Does the top graph have -2 shaded? Yes, because of the bracket. So I put a bracket on -2. How about 0? Does the bottom graph have 0? No. The bottom graph doesn't have 0 because of the parentheses. So the bottom graph doesn't have 0. If either graph has a parentheses, then you have to put a parentheses at that number. So there'll have to be a parentheses at the 0 because they don't both have 0. Because the bottom graph has a parentheses at 0. That means you've not shaded 0. So that's actually your answer there. Alright, same thing with example 6, except this time it is a union. Same numbers, right? So put them in order, -4, -2, 0, and 1. This time we're doing a union. So we're doing -4 to 0. You could actually look at the previous graph if you wanted to, and from -2 to 1. This is where you graph everything. So what's the smallest number that we've graphed? -4. What's the largest number that we've graphed? 1. So if we union these two sets, we have to show everything that both sets have. So actually, if we put those two sets together, if you actually take that top graph and slide it down, it would connect, and you would go all the way from -4 to 1. Do we have -4? We don't have -4, okay? So it would be a parentheses, but do we have +1? Yes, so it would be a bracket. So your union between those two sets would be all the numbers between -4 and 1, not including -4, but including 1. All right, example 7. -infinity to 6, intersection 2 to 9. So we're looking at all the numbers from -infinity to 6, and we're trying to see what they have in common with all of the numbers between 2 and 9, and they're asking you to graph. So infinity doesn't go on your number line, so I'll only have 3 numbers on my number line. They'll be in this order, 2, 6, and 9. They don't have to be. Don't spend a lot of time on your graph. Just slap the numbers down, make sure they're in order. Graph -infinity to 6. That'd be shade the left arrow, go all the way up to 6, put a parentheses there. And then you're going to union that with bracket 2 to 9. All the numbers from 2 to 9. And I said union, but it's intersection. So looking at your graphs, where do these two graphs have numbers in common?
2 and 6.
From 2 to 6. Do we include 2? Do we need a bracket or parentheses at 2? A bracket or parentheses at 6? Parentheses. Alright, so we're going to use 7's graph because the numbers are exactly the same. We won't redraw the graph for number 8, but this time change it to a union. So if we take our graph from 7 and we do a union, we just include everything that we've shaded. So that means we're going to shade, what's the smallest number that we've shaded? Negative infinity. Okay, negative infinity is not an exact number. So when you use negative infinity or positive infinity, you always use a parentheses. You can't reach an exact number of negative infinity or positive infinity. So you always use a parentheses on infinity. And then we're going all the way to 9. Do I have a 9 or am I just approaching 9? I'm just approaching 9, so I use a parentheses there. All right, any questions about that set of problems? So really those first 8, I'm trying to teach you something new called interval notation. And it's a notation that we use in Algebra II and at pre-cal and cal and all those levels of math above Algebra II and above. All right, if you'll flip your notes over, this is the part that you're probably familiar with. Solving inequalities. Don't flip them over yet. Sorry. 9 and 10. Sorry. Got ahead of myself. What two numbers go on my number line for number 9? 2 and 4. Is this an intersection or a union? It's an intersection, so I'm going to shade bracket at 2, means I'm including 2, and I'm going to go to positive infinity. And then I'm going to do the interval from 4, not including 4, so I use a parentheses, to positive infinity. And this is an intersection. So these two graphs have points in common from 4 all the way to infinity. Okay? Since the top graph doesn't include 4, that means both graphs don't have a 4. So you'll have to use a parentheses on the 4. And we always use a parentheses on infinity because I can't get to an exact number of infinity. 10, we can use 9's graph. If we do a union of those same two intervals, what would be the union of those two sets? So if you could actually take that top graph and just slide it down and put it on the bottom graph, that would be all the numbers from where to where?
Infinity to infinity.
What?
Infinity.
2 to infinity. 2 to infinity. So if we did a union of those graphs, that would be all the numbers between 2 to infinity, including 2. Okay, on the back of your notes, this is where we're going to review solving less thans and greater than, solving inequalities. This part I think you've done before. Who can remember what flips the inequality sign? What can you do in an equation that flips the inequality sign?
Dividing by a negative number.
Okay, so we might want to write down flip. So I agree with dividing by negative, but it's also dividing or multiplying by a negative number. Anytime we're solving an inequality, that means a less than or a greater than problem, and we divide or multiply by a negative number, that's going to flip your sign. That's going to flip your inequality sign. Anytime you're dividing or multiplying by a negative number, that's going to flip your inequality sign. Other than that, inequalities are solved just like equations. So in example 1, we need to solve for x, so our first step would be subtract 5. That would give us 2x is less than 12. Adding and subtracting never flips your inequality sign, only multiplying and dividing by a negative number. So then we're going to divide by a positive 2. That's not going to flip my sign. And I'm going to get x is less than 6. The directions say, other than no solution, use interval notation to express your solution sets and graph each solution on a solution set on a number line. So let's graph first, and then we'll write our interval notation. So we're going to graph all the numbers that are less than 6. So you'll put 6 on your number line. Would I use a parentheses or a bracket? Parentheses. You're going to use a bracket when there's an equal to on your inequality. Would the parentheses face to the left or to the right? It's going to face to the left because that's a less than sign, and so we're going to shade all the numbers that are less than 6. Now they want you to write that interval that we shaded, write the interval of the numbers that we shaded. So what's the smallest number that we've shaded? Negative infinity all the way to the largest number, which is 6. Did we shade 6? No, because it was just less than, so we use a parentheses there. We always use a parentheses on negative infinity or positive infinity because that's not an exact number. Example 12, we got to solve for x, so we're going to divide both sides by negative 5. Because we're dividing by a negative number, the sign must flip or switch. 30 divided by negative 5 is negative 6. So our answer is x is greater than negative 6. That's all the numbers that are greater than or equal to negative 6. We put negative 6 on our number line. I don't care if you have 5 numbers. Just put the number that you solve for, bracket or parentheses. Bracket facing to the right because we're doing a greater than. And we would shade all the numbers that are greater than or equal to negative 6. Then we would write all those numbers in what we call interval notation, and that would be bracket, negative 6, comma, infinity, parentheses. The smaller number comes first, and the larger number comes second. Okay? Small number comes first in your interval notation, the larger number comes second. Any other questions? Alright, your inequalities can get just a little bit harder, but nothing like the equations that you solved last night. So why do we not, or what is it about example 13 that we would want to take care of right away? We don't want to get rid of those denominators. So what number can we multiply by that 6 and 12 will go into? 12. Okay, we have to have a number big enough that 6 will cancel into and 12. So you could use 12, you could use 24, but 12 is the smallest number that 6 and 12 would go into. All right, we're going to multiply everything by 12. So when I multiply 12 times the first term, 6 cancels into 12 2 times. So I get 2 times parentheses 4x minus 3. When I multiply 12 times the second term, nothing cancels. So you have to do 12 times 2, which is 24. Put your greater than or equal sign down. Multiply times the last term. The 12s cancel. And you just get 2x minus 1. So you always want to clear your fractions by multiplying through by something that your denominators will cancel into. And then the rest of it, again, y'all have done such difficult problems compared to this one. Y'all ought to go, yeah, this is good. I can do this. The left-hand side has some like terms. What's a negative 6 and a positive 24? Positive 18. I'll have x's on both sides. So which one's the smallest? 2x. So I'm going to move the smaller one where the larger one is. Hopefully that'll help me keep not having any negative x's. And then we're just solving, just like we would solve an equation. Okay, I feel like I've done something wrong. I'm getting a negative 19 and 6 will not go into it. I can get decimals or fractions. Do y'all notice anything I've done wrong? Got the same thing? Okay. Yeah, we really like to get whole numbers, and that makes me kind of feel like I've done something wrong. But we're going to get x is greater than or equal to, and I can't reduce 19 over 6, so I'm just going to leave it as negative 19 over 6. So you can get decimals or fractions. It does make you think that you've done something wrong. Just go back and make sure that your math is correct, and then we're going to graph this. I'll graph it up here. So we put negative 19.6. Our inequality says we're graphing all the numbers that are greater than or equal to negative 19.6. So I'll use a bracket that's facing to the right because of the equal sign. And it's facing to the right because I'm shading to the right. So you're going to shade all the numbers that are greater than or equal to negative 19 over 6. And then you will write interval notation for that, which will be bracket negative 19 over 6, comma, infinity parentheses. Because there's an equal to, there's an equal to right here, greater than or equal to. So I would always use a bracket if I had an equal to. If I don't have a equal to, I would use a parentheses. Bracket means equal to or closed circle. Parentheses means less than or greater than, no equal to, or open circle. All right, questions about 13? All right, last set of directions say solve each compound inequality. Solve each compound inequality. So in example 14, you know that it's compound because it has two inequality signs. So compound, if you think about a compound sentence, is that not two independent clauses put together? It's compound. There's two of them. So you have to have two inequality signs to make it a compound inequality. And in example 14, you see the two inequality signs. So I'm pretty sure you've done some of these in Algebra 1, but you may have totally forgotten them. So when we read example 14, we read it as two separate inequalities. The first inequality is 3 is less than or equal to 4x minus 3. Okay, and then we're going to use the word and then we have 4x minus 3 again. But in the second inequality, it's telling us that 4x minus 3 is less than 19. Okay, so when we read the problem, we read it with an and. 3 is less than or equal to 4x minus 3. And 4x minus 3 is less than 19. That's just how we read that. You also need to know that and is the same thing as intersection. And is the same thing as intersection. You're going to solve each one of the inequalities, and then we'll graph the intersection of the two inequalities. Now, I do not like for my variable to be on the right-hand side. You may have noticed that. If my variable's on the right-hand side, I just reverse the problem, and I put the 4x on the left. I just have to make sure that I don't change my sign. So the open end of the inequality is still facing the 4x. I graph better when my variable's on the left-hand side, and I solve better when my variable's on the left-hand side, especially graphing. Divide both sides by 4, reduce, and you get x is greater than or equal to 3/2, or 1.5, or 1.5. Doesn't matter which one you use there. On the right-hand side, we're going to add 3 to both sides. We're going to get 4x is equal to 22. We're going to divide by 4, and we're going to reduce, and we're going to get x is less than 11 over 2. So we're graphing all the numbers that are greater than or equal to 3/2, and then we're graphing the intersection with all the numbers that are less than 11/2. So you'll draw your number line, You've got to decide which number is the smallest because it'll go on the left. Three halves or 11 halves? 3 halves is smaller, it goes on the left. 11 halves goes on the right. You're doing an intersection because that's what and means. So you'll graph all the numbers that are greater than or equal to 3 halves. Then you'll graph all the numbers that are less than 11 halves. You'll do that kind of above your graph. I'm going to change colors here. And then you're doing an intersection. What points does the red graph and the yellow graph have in common? Where do they share points? Between 3 halves and 11 halves. So my interval goes from 3 halves to 11 halves. Do both graphs have 3 halves? Yes, because of the bracket. Do both graphs have 11 halves? No, remember we're doing an intersection, so we're doing what they both have. So if they both don't have 11 halves, then you have to use a parentheses. So I think you've done compound inequalities before. Have you done ands and ors? You probably just haven't done the interval notation, but you've done the graphing part. So the interval notation is kind of the new part on that. All right, example 15 will not be as long. It's considered a compound inequality because of the absolute value. Example 15 is considered a compound inequality because of the absolute value. So after solving your equations with absolute value, you know what's inside could be positive 5, or you know what's inside there could be a negative 5. So you're going to do x is less than positive 5. Then if it is a less than sign, it's going to be an and. If it were a greater than sign, then it would be an or. Okay, less than is an and problem. A greater with an absolute value is an or problem. And then you do your x again, and you have to change positive 5 to negative 5. And when you change to the negative number, you also have to flip your sign. Okay? So you have to flip your sign, and you have to change positive 5 to negative 5. So all the changes happen on the right-hand side. So if you have absolute value is less than 5, that reads x is less than 5, and because of the less than sign, x is greater than negative 5. Draw your number line. Negative 5 goes on the left. Positive 5 goes on the right. An and is an intersection. So you're going to graph all the numbers less than 5. That would be parentheses, shade to the left. And all of the numbers greater than negative 5. That would be parentheses at negative 5, greater than, shade to the right. And you're looking for the intersection. Where do these two graphs share points? Between negative 5 and 5. Parentheses on both sides. Neither one of those have a bracket. So pick a number in between negative 5 and 5.
Negative 4.
Negative 4. So if you plug that back into the original problem, is the absolute value of negative 4 going to be less than 5? Yes, because the absolute value of negative 4 is 4, and 4 is less than 5. Pick another number in your interval. 2. Is the absolute value of 2 less than 5? So any number between negative 5 and positive 5 would be a solution to your original problem. Why no brackets here? Yeah, because the original problem says less than 5. So if you put negative 5 in and took the absolute value, you would get 5 is less than 5, and that's not true because 5 is equal to 5. So negative 5 cannot be a solution and positive 5 cannot be a solution, but anything between those two numbers are. All right. The next one is also an absolute value, but it's an absolute value with a greater than sign. So that just means we're going to have an or. We drop the absolute value and we write x is greater than or equal to 5. Because of the greater than sign, this is an or and not an and. An or represents a union. Okay? Because its absolute value is greater than, not the equal to part, but just the greater than means it's an or. Then your second inequality is x. Flip your sign. Change positive 5 to negative 5. Drop the absolute value. Write the problem just like it is. Because it's a greater than sign, it's an or, which means union. And then you do x. Flip your sign. X is less than or equal to, change positive 5 to negative 5. Put your two numbers on your number line. Graph it like an or. So we're graphing all the numbers that are greater than 5, greater than or equal to 5, and all the numbers that are less than or equal to 5. And that's what our graph would look like. So this one's different. This one's a little bit different. When we write our interval, we actually have two intervals. We have an interval on the left, and we have an interval on the right. Okay? Or means you're graphing everything. So the interval on the left would go from negative infinity to negative 5 bracket. This is a union problem, so you would place the union symbol next, and then you would have bracket, and then you would have 5 to positive infinity. So this is the first graph that we've seen that has two separate intervals. There's no way to write all those numbers in one interval, so we actually have to use an interval for the left-hand side of the graph, and we have to use an interval for the right-hand side of the graph.
So it's a union if it's a greater than or equal to.
Absolute value and a greater than sign.
Okay.
So pick a number on the left interval. Pick a number in the left interval. Negative what? Negative 6. Plug it back into the original problem. Is the absolute value of negative 6 greater than or equal to 5? Yes, it is. Pick an interval number on the right-hand interval. 100. Is the absolute value of 100 greater than or equal to 5? So you could have any numbers to the left of negative 5, including 5, or to the right. All right. Example 17. You just have to know to get your absolute value by itself. So first you would add 3. And you would get 5 times the absolute value of 2x plus 1, bless you, is greater than or equal to 12. And then you would divide both sides by 5. 5 is not going to go into 12, so you can leave it as a fraction. You can change it to a decimal if you want to. You may know what 12 divided by 5 is. 2 point what? 2.4. Let's use a decimal for this one. All right. Would this be an and or an or? It's an or because it's a greater than sign. So we're going to have two inequalities. 2 means compound. 2x plus 1 is greater than or equal to 2.4. This is an or, which is a union. And then we're going to have 2x plus 1 is less than or equal to, flip your inequality sign, and then make 2.4 negative. You'll solve each one of those. You have 2x is greater than or equal to 1.4. Divide both sides by 2. X is greater than or equal to 0.7. Over here you'll subtract 1. You'll get 2x is less than or equal to negative 3.4. Did I do something wrong? X is less than or equal to negative 1.7. Put those numbers on a number line. Small goes on the left, larger one goes on the right. Graph each interval. And write all your answers in interval notation. So you have two separate intervals. So you'll have two. You have two separate graphs, so you'll have two separate intervals. The one on the left would be written how?
Parentheses, negative infinity, comma, negative 1.7 brackets.
Okay, and then you would use a union symbol, and then you would do bracket,
2.7, positive infinity,
parentheses. All right, last one. Y'all have survived chapter 1. This is the last section in chapter 1. Everybody finished copying? Okay. All right, last one. It says y is equal to 8 minus the absolute value of 5x plus 3, and y is at least 6. Y is equal to 8 minus the absolute value of 5x plus 3, and y is at least 6. So in our previous problems, they've told us that y is equal to 0 or y is equal to 10. So this time they're using at least, which means an inequality sign. Okay? And again, I like for my x's to be on the left-hand side. So I'm going to put the 8 minus 5x plus 3 in absolute value. I'm going to put that on the left-hand side. And I know 6 is going to go over here on the right-hand side. I know I'm going to use less than or greater than. You just got to read the problem and figure out which one. So it says y is at least 6. Y is at least 6. Somebody said greater than, somebody said less than. So let's just stick it in. It is an equal to, right? So if y, okay, let's pretend that this is y over here. If y is at least 6, then you're really looking over here at this side. All right, so what numbers could this left-hand side be if they're greater than or equal to 6? Does that mean at least 6? So the left-hand side could be 6 or 7 or 8.5 or, do y'all see that? If you put a less than sign, that would make y at the most. All right, so you might have a few little word problems where you're going to have to read them and set them up, but I've already showed you how to solve everything. So just leave this one just set up. I don't even have the answer for it, but we'll just leave it like this.
Hey, Miss Pettis told us to show you this.